Welcome to Pottorff's Behind the Blades, Not a Podcast. In today's episode, we're discussing something that sounds simple, but gets misunderstood all of the time: intake versus exhaust. On drawings, they can look almost identical. Same size opening, same louver, but they're doing very different jobs. My name is Stephenie Ravenscroft, and joining me is Josh Parent.
Hello, Stephenie.
Hey, Josh.
So let's break down what actually matters when deciding whether your louver is running in an intake or an exhaust configuration and why understanding the difference is so important.
Josh, let's start with the basic difference.
At the most basic level, an intake louver brings air into the building, and an exhaust configuration pushes air out. From a performance standpoint, intake air is what you care about protecting. Whatever comes through that intake is heading straight towards equipment and inevitably occupants.
Exhaust air is already leaving the building. Intake air has to be clean, dry, and controlled.
That difference alone drives many design decisions.
Let's start with what matters when referring to intake on louvers.
Sure. Intake louvers are all about protection. Rain, wind-driven rain, and debris.
This is where blade shape, depth, and drainability really matter, huh?
Yep. You'll often see drainable or wind-driven rain rated louvers specified for intakes, especially on critical buildings such as fire and police stations, 9/11 call centers, hospitals, and schools. Now, pressure drop matters here too. Whatever resistance the louver creates directly impacts the fan and system performance. As we talked about in previous podcasts, higher pressure drop results in higher cost.
That's why intake louvers usually get more scrutiny during its submittals.
Yep. Now let's talk a little bit about exhaust. Exhaust louver configurations are certainly more forgiving. The air is leaving the building. Water intrusion is not really an issue. Any water that might be pulled in on the intake side of the system is instead pushed away from the building.
That's why simpler blade types are often used on exhaust: J blades, airfoil blades, and shallow profiles.
And pressure drop still matters, but water performance shouldn't be a concern. Exhaust placement is important. You don't want exhaust air short-circuiting back into an intake. And if your exhaust handles grease, smoke, or other contaminants, material selection and code compliance really matter.
I guess we should talk about mistakes. One common mistake is specifying the same louver for intake and exhaust without considering function. Just because it fits the opening doesn't mean it fits the application.
Exactly right. Another issue is undersizing intake louvers, which increases air velocity and water carryover. And sometimes exhaust louvers are over-designed, adding unnecessary pressure drop with little to no benefit.
So let's talk about some good rules of thumb. If it's intake, prioritize weather protection and verified performance data.
And if it's exhaust, prioritize airflow efficiency and code compliance. Always check your velocity, pressure drop, and louver separation distances.
And remember, louvers are a part of a system, not standalone components. Here's the bottom line and the conclusion to this podcast: intake versus exhaust. Same category, but very different responsibilities. Understanding the difference early makes selection easier and systems perform better. If you'd like to learn more, visit us at www.pottorff.com. Thanks for joining us for this episode of Behind the Blades.